Hey everyone, welcome back to LabCoatz. Alright, riddle me this. What do coffee, tea, and chemists all have in common? I'll give you a moment to think about it. If you said they're all bitter and distasteful, you're not wrong, but the answer I was looking for was caffeine. This naturally occurring alkaloid is by far the most widely used recreational drug, and for some reason, chemistry YouTubers really seem to have a thing for it. Almost every small channel has tried extracting caffeine at least once, and some, like Now Red, have done so multiple times. It's become so iconic at this point that there are even channels like Now Green making parodies of it. So a few months ago, I figured it was finally time for me to join in on the fun. Personally though, I just couldn't see myself performing the same old caffeine extraction as everybody else. That would be kind of boring, and it has definitely been overdone at this point. So I thought to myself, what would not be boring? Well, what about actually synthesizing caffeine from scratch, and then using it to make some kind of homemade energy drink? Did I mention YouTube chemists also have a thing for energy drinks?
I'm a monster boy. Don't talk to me till I've had my morning heart palpitation.
Making caffeine would certainly be cool, but if I was going to go through the trouble of synthesizing a stimulant for an energy drink, I would have to cook up something much stronger. This is 3,7-dimethyl 1-allyl xanthine, otherwise known as 1-allyl theobromine. For simplicity though, I'll just be calling it DMAX, or DMAX for short. When compared to caffeine, you can see there really isn't much of a difference. Both compounds are alkyl substituted xanthines with methyl groups at positions 3 and 7. However, the position 1 nitrogen on DMAX has an allyl functional group instead of the same boring methyl group as caffeine. And this allyl group causes some major changes in biological activity. You see, caffeine targets both the A1 and A2 adenosine receptors, which play roles in stimulating the cardiovascular and central nervous system respectively. Compared to caffeine, DMAX is slightly weaker at the A1 receptors, but 5 to 10 times stronger at the A2 receptors. What does that mean? Well, according to the research I've done, it means this compound should have far stronger stimulant and performance-enhancing effects, while also having less impact on the heart. Plus, similar analogues are also known to possess antidepressant properties, which, to me, kind of makes this sound like the perfect caffeine substitute. Now, I know some of you are probably saying something along the lines of, "Oh, you can't make something like that, that's basically meth, you'll go to jail." Well, actually no. Unlike amphetamines, xanthine analogues are largely uncontrolled, way less addictive, and fairly safe by comparison, although I still wouldn't recommend experimenting with them. Everything I did was for educational purposes only, and I take zero responsibility for anyone who hurts themselves attempting to replicate my work. And with that out of the way, let's get started. To make DMAX, I use the following ingredients: theobromine, allyl bromide, potassium carbonate, and dimethylformamide, which acted as the solvent for this reaction. Most of these chemicals were bought on Amazon, but I had to prepare the allyl bromide myself from pineapple perfume. You can see how in my previous video. To kick things off, a 250 milliliter beaker was filled with 180 milliliters of dimethylformamide. Then, 6 grams of fluffy theobromine powder was weighed out and added with strong stirring. Despite DMF being one of the best solvents for it, theobromine just isn't that soluble in most solvents, so most of what I added remained undissolved. With the solution still mixing, 4.6 grams of food-grade potassium carbonate was measured and gradually incorporated into the slurry. Again, not much dissolved, but that's to be expected, and I moved on to adding the final ingredient, 4.06 grams of allyl bromide. Volume-wise, that's about 3 milliliters. And with that added, the reaction was finally underway, so I covered the top with plastic wrap and allowed the solution to stir overnight at room temperature. The reaction that's taking place here is known as an N-alkylation, which is a type of nucleophilic substitution. Basically, the position 1 nitrogen attacks the carbon on allyl bromide, kicking off the bromide group to yield this intermediate molecule. Then, the extra hydrogen on the nitrogen links up with a carbonate ion from the potassium carbonate to form this bicarbonate ion and our final 1-allyl theobromine, or DMAX. If you're wondering about the free bicarbonate and bromide ions, they simply reconnect with the leftover potassium ions to form the corresponding salts. This whole reaction is unfortunately a bit slow since the reactants aren't that soluble, so reaction times in excess of 12 hours are often needed. It's also worth noting that this reaction should work with basically any alkyl halide, given enough time. For instance, using propargiobromide yields the similar compound DMPX, and with methyl iodide, you should get plain old caffeine. After about a day, the reaction hadn't really changed in appearance, but in theory, it should have been done reacting, and that meant it was time for the tricky part: isolating the product from solution. Normally, this can be done by simply boiling off the solvent, but in this case, that really wouldn't be the best option. You see, dimethylformamide has a rather high boiling point, so removing it all would be a bit of a pain, and it could result in damage to the end product. And plus, DMF itself tends to break down at its boiling point, yielding a poisonous cocktail of carbon monoxide and gaseous dimethylamine. I tried distilling it off under vacuum, which is what a lot of papers recommend, but I found the whole process to be way too slow and finicky. To be honest, I was probably approaching it wrong by heating and then pulling a vacuum, but whatever. After that, I tried filtering the hot solution and then cooling it on ice to crush out the product. In hindsight though, most of the DMAX was probably already dissolved, and the stuff that did crush out was most likely contaminated with the less soluble theobromine and potassium salts. So, with all of my other options expended, air drying the filtered solution ended up being the only reliable method for driving off the solvent. As mentioned before though, dimethylformamide has a rather high boiling point and really isn't that volatile, so the process did take a few days, even with everything poured out onto a sheet. But in the end, I did get a decent amount of solid product. If you look closely, you can actually see that most of the material had crystallized, as opposed to simply crushing out as an amorphous paste. The crystalline nature of the product was a good sign of purity, but it still needed a bit of cleaning up before it could be tested. To purify the DMAX, I loaded everything I obtained into a small beaker, and then added about 75 milliliters of water for recrystallization. The mixture was then heated and stirred until everything dissolved, leaving a yellowish-brown solution. The color here is most likely from some of the DMAX degrading, since the allyl functional group does make it somewhat sensitive to light. There was also some other junk floating around, but it was easily removed with a quick filtration. As the solution cooled, a bunch of lovely white crystals began to fill the beaker. Any leftover potassium salts and DMF should have remained in solution due to their high solubility, so in theory, DMAX should have been pretty much the only material crashing out. Unfortunately though, this is one of those reactions where you start with a white powder, add a colorless liquid, and end with another white powder, so it's really hard to tell if it actually worked just by looking at it. I do have a test though, and thankfully, it's a bit more colorful than the main reaction. These two test tubes are filled with a dilute solution of potassium permanganate, which is a fairly potent oxidizer with a strong purple color. In theory, a solution like this shouldn't affect plain theobromine. However, if the reaction was a success, the permanganate should readily attack the alkene double bond on the allyl functional group, giving a visible color change as it's depleted. To test this, a scoop of theobromine was added to the test tube on the left, and as expected, nothing really happened. So, now that I confirmed the permanganate wouldn't give a false positive with the starting material, I tried adding a bit of the product to the other test tube, and almost immediately, it began to change colors. It shifted from purple to more of a red, and eventually it all went brown. This is the color of manganese dioxide, which forms as the permanganate is reduced. And in this case, that means the reaction was probably successful. I say probably because even though I followed a well-established procedure with all the required chemicals, it's still possible that I formed a different molecule with more allyl groups attached, or that I was lied to by the Amazon seller and didn't even start with theobromine. To rule out both of these possibilities, I decided to perform every home chemist's favorite crude analysis, the melting point test. A small amount of theobromine was added to a clean test tube and heated slowly with a torch. Optimally, the heat would be more carefully applied using an oil bath or heating block, but neither of these were an option for me at the time. Eventually, at around 350 degrees Celsius, everything began to melt, and some material even started to sublimate. This is pretty much the exact behavior expected from theobromine, so it seems safe to assume that my starting material was fairly pure, and not tainted with other xanthine analogues. Alright, so the theobromine was good, but what about the end product? There aren't very many sources that talk about the melting point of 1-allyl theobromine, but I did find one paper that listed it among other analogues. Here it is reported to melt at 143 degrees. However, the material I made appeared to begin liquefying at only 120 degrees, probably because it wasn't fully dry. I tried torching the water out in the tube, but that didn't seem to work very well. In the end though, this did at least confirm that I wasn't just playing with unreacted theobromine. There is still a slim possibility that some of the product was alkylated a second or even third time, yielding compounds like 7-methyl-1,3-diallylxanthine, but this is very unlikely since all other nitrogen positions on theobromine are blocked by methyl groups. So, after all this work, I came out with 4.3 grams of what I'm reasonably concluding is slightly damp DMAX, 3,7-dimethyl-1-allylxanthine. This correlates to a yield of roughly 59%. I think the highest reported yield I saw was 74%, so I guess this isn't too bad. According to one of the papers, adding hydrochloric acid during the recrystallization could help crash out more product, but I was honestly quite satisfied with what I got, since it was way more than enough for me to use in my cursed energy drink. And speaking of, I feel like now would be as good a time as any to talk about safety. There's really no way to sugarcoat this. Drinking homemade chemicals is extremely unwise, especially if they are untested synthetic stimulants. Just because something's legal doesn't mean it should be going into your body. I did weeks of research, calculated a theoretically safe dose based on animal tests and confirmed biological activity, and even then, I was still nowhere near safe enough by professional standards. So please, don't replicate what you're about to see me do. Initially, my plan was to make 2 energy drinks, one with 20 milligrams of theobromine as a control, and another with 20 milligrams of DMAX. In theory, the theobromine would have had little to no effect due to its weak stimulant properties, while the DMAX should have caused effects similar to an ordinary energy drink with 100 to 200 milligrams of caffeine. But as you'll see in a minute, things didn't exactly go as I had hoped, and I ultimately paid the price. Putting the doom and gloom aside for a moment, here's how I actually made the energy drink. First off, the ingredients. I utilized 3 limes, 2 lemons, 1 orange, 1 pear, half a cup of sugar, half a cup of water, carbonated water, and an assortment of herbs and spices that I thought would be good in a beverage like this. Coriander and ginger were included because they seem to pop up a lot in homemade cola and soda recipes, and I added the nutmeg because it reminded me of herbal root beer. Fennel was used to add a licorice-like flavor and some sweetness. And finally, I threw in a bit of tarragon because I thought the name sounded kinda cool. If you're wondering about the pear, it turns out this is actually a key element in many homemade versions of Red Bull, so I was hoping it would somehow make my drink more energy drink-like. To be honest, the stuff I came up with tasted nothing like Red Bull or any other energy drink, but I tried my best. To get started, I zested all of my citrus fruits and added the zest to a jar with half a cup of sugar. If you leave this mixture for long enough, it will eventually become a flavorful syrup called an oleosaccharum, but I was impatient and simply moved on with what I had. In hindsight, this probably contributed a fair amount of bitterness, but if you ask me, energy drinks are supposed to be kind of medicinal and bitter anyway, right? Moving on, I next added my melange of spices to the zesty sugar jar. Again, this included a teaspoon of coriander, a teaspoon of ginger, and a 1/4 teaspoon of nutmeg, along with a tablespoon of tarragon and 1½ teaspoons of fennel. These ingredients were mixed together thoroughly and allowed to get acquainted. Meanwhile, 2 limes and a lemon were halved and juiced directly into the jar. I tried finding a way of doing this that didn't shower me in my countertop in fruit juice, but eventually, I was forced to accept my fate. Once everything was nice and sticky, I chopped the pear into medium-sized chunks and, like everything else, added it to the jar. And with all the basic ingredients incorporated, I added half a cup of water and then microwaved the mixture until the pear chunks softened. Then, I used a strainer and coffee filter to recover the syrup, which didn't exactly look very appetizing. I would dye it, but the last time I tried that, everybody complained about me for using artificial food colors and cheap ingredients. So this time, I decided to leave the syrup its natural color and only annoy people with my use of cheap ingredients. Alright, this is the part where things get interesting. 2 bottles were prepared with labels on the bottom to indicate whether the drink contained theobromine or DMAX, and each one was filled with a 50-50 mix of carbonated water and my homemade energy drink syrup. Then, using my trusty scale, I measured out 1 portion of theobromine and 1 portion of DMAX, which were added to their respective bottles. And this is where I majorly screwed up. Like I said earlier, my plan was to take 20 milligrams of each substance on separate days to determine how effective DMAX was as a caffeine substitute. But, in what is possibly one of the worst rookie mistakes of all time, I misread the scale and accidentally weighed out 200 milligrams instead of 20. For theobromine, this is honestly no big deal, since it has very weak biological activity in humans. DMAX, on the other hand, is quite a bit more serious. 200 milligrams is equivalent to the lowest dose of the nearly identical propargyl analog given to mice in lab tests. So in theory, it shouldn't have been anywhere near the lethal dose. However, in terms of strength, this amount is potentially equivalent to almost 2 grams of caffeine. That's 2,000 milligrams, up to 10 times the amount found in an energy drink, and 5 times the recommended daily maximum. So, how did it all play out? Well, I first mixed up the bottles to ensure I had a proper blind test, and on the morning of my first trial, I pulled one out of the fridge and shotgunned the whole thing. Immediately after drinking it, I didn't really notice anything strange. But after about an hour, things started to get interesting. Alright, quick little update here. I drank my first bottle of the energy drink this morning, and I'm feeling a bit more anxious than usual. I just wanted to take note of that. I don't think it's because of the energy drink. I think it's because I'm naturally a bit of an anxious person, so I guess I'm a little bit anxious from, not knowing what exactly I just drank and not knowing exactly what it will do. I know what I should expect it will do, but, there's naturally a bit of a gray area with that, and just not knowing is, I guess, enough for me to be a bit more anxious than usual. And just a little bit more shaky, just because of that, but, yeah. I don't think this is from that. I think this is just me. It wasn't just me. I tried convincing myself that it was, but after another hour of increasingly worse shaking and shivering, I was pretty confident about which bottle I had drank. So I caved in, called off the blind test, and checked the label, which confirmed my fears. I had indeed chugged the spiked energy drink, meaning my symptoms weren't from anxiety, but from a 200 milligram dose of DMAX coursing through my bloodstream and nervous system. And let me tell you, 200 milligrams of this stuff isn't an amount any sane person would enjoy. When the effects hit their peak, my arms and legs were shaking so much that I was worried about experiencing an actual seizure. Not fun. I wish I had some video of this to share, but I wasn't exactly worried about filming stuff at the time. Shocking, right? Moving on, let's talk about how this stuff felt as it took effect in my body. First and foremost, the onset time of this stuff seemed to be way longer than caffeine. While caffeine can take as little as 30 minutes to reach peak activity, DMAX seemed to reach its peak after roughly 5 hours, with noticeable effects picking up after the first 1 to 2 hours. And really, I have no idea why this is. DMAX is more soluble than caffeine, but its molecules are slightly larger, so maybe it has a hard time entering the fatty tissue of the human nervous system. That'd be my best guess, but I could be totally wrong. The other thing I noticed was just how well this compound matched its expected performance. Earlier, I stated that DMAX should have stronger stimulant properties than caffeine, while also having less impact on the heart. And I can say after taking 200 milligrams, I think my conclusions were totally on point. Obviously, I experienced the shaky, jittery muscle movements associated with high doses of most stimulants, including caffeine. But beyond that, I also felt hyper-focused on most tasks I undertook, even though I didn't score noticeably higher on any of the reaction time, memory, or aim tests I tried, which seems kind of weird. Regardless, compared to an energy drink with 200 milligrams of caffeine, my 200 milligram shot of DMAX definitely gave me a way bigger buzz. And while I didn't try any physical exertion tests, I'm pretty sure I would have noticed at least some level of performance enhancement, given how hyped up I felt. And regarding the cardiovascular symptoms, I felt absolutely none of the unpleasant side effects on my heart that I typically do with caffeine. Despite me literally shaking from nervous system stimulation, my heart rate and blood pressure were relatively normal, and an EKG taken during the compound's peak activity showed no signs of an irregular heart rhythm, which is pretty incredible. Again, I don't endorse taking this stuff, since the long-term effects are unknown and there is the potential for addiction. But with enough research and a more appropriate dose, I do think this stuff could be a decent alternative to regular caffeine. Maybe. Still, don't expect to be seeing this stuff on store shelves anytime soon. Alright, I think that's pretty much everything I've got. I hope you've all enjoyed this little quest into the intriguing and somewhat underrepresented world of xanthine analogues. If so, be sure to hit that subscribe button, because I've got a lot more interesting stuff on the way, such as cooking a legal analog of methamphetamine. And if you want to help support me and my work, consider donating or becoming my patron on Patreon. The links, as always, are down below. A special thanks goes out to all the existing LabCoatz supporters. Without their support, I wouldn't be able to afford many of my projects, and you all wouldn't get to see me do things like smell horrible chemicals, build cool projects, or ingest things that I probably shouldn't. So thank you to everyone who stuck around until now. Remember to like, share, and subscribe, and I'll catch you next time. LabCoatz, out.